Imagine standing under a star-speckled sky, surrounded by the serene silence of a remote wilderness, when suddenly, the heavens erupt in a breathtaking display of color. A shimmering curtain of greens, pinks, and purples dances across the night sky. It's a mesmerizing spectacle that seems almost otherworldly. But have you ever paused to wonder, why do auroras happen? What mysterious forces of nature are at play to create these stunning northern lights? Stay with me, because we're about to peel back the layers of this cosmic phenomenon, unlocking the mysteries that lie within the vibrant lights that capture the imagination of millions. As we embark on this journey, you'll gain valuable insights into the scientific marvels that create these stunning displays, insights that will deepen your appreciation for the natural world and remind you of the beauty that lies beyond our everyday experience. You might be surprised by how interconnected our planet is with the cosmic process that gives rise to these natural light shows. So let's dive right in. You're about to discover the awe-inspiring forces that cause the auroras to dance on our planet. To grasp the wonder of auroras, we first need to understand where they originate: the sun. Yes, the giver of life on Earth is also a powerful force that sends streams of charged particles our way. Every day, the sun emits a continuous flow of energy known as the solar wind. This invisible stream consists of electrons and protons traveling at incredible speeds towards the Earth. What's remarkable is that this solar wind isn't constant, it fluctuates, and during solar flares or coronal mass ejections, it becomes particularly intense. Now, you might be wondering, what happens when this solar wind encounters our planet? Earth is enveloped by a magnetic field known as the magnetosphere, which acts as a shield, protecting us from the harsh solar radiation. This magnetic field is a vital player in the formation of auroras. As the solar wind collides with the magnetosphere, it creates complex interactions that we are just beginning to fully comprehend. Think about it. The very air we breathe is alive with particles that, under the influence of solar wind and Earth's magnetic field, transform into radiant energy. But how does this energy translate into those spectacular displays we see in the night sky? Here's where the magic happens. As charged particles from the solar wind penetrate the magnetosphere, they are funneled towards the poles of Earth by the magnetic field lines. This is because the magnetic field is strongest at the poles, creating a natural gateway for these particles. When these high-energy particles collide with gases in our atmosphere, primarily oxygen and nitrogen, the results are stunning. As the charged particles crash into these gases, they excite the atoms, causing them to emit light. This is similar to how fluorescent bulbs work. The colors of the auroras depend on the type of gas involved. For instance, when oxygen is excited at higher altitudes, it can produce red and green lights, while nitrogen produces blues and purples. Isn't it fascinating that the colors of the aurora are influenced by the very elements that compose our atmosphere? Picture this: you're standing in the Arctic night, surrounded by snow-capped peaks. The dark sky is suddenly illuminated as the northern lights flicker to life. You might see shades of vibrant green dancing gracefully overhead, occasionally cut through by flashes of deep violet or blush pink. It feels like a cosmic ballet, choreographed by forces far beyond our comprehension. But did you know that the aurora's behavior also varies dramatically? Sometimes they are fast and flickering, while at other times they are slow and rippling, resembling a silk curtain billowing in the wind. What causes these differences? That's a question that even experts are still investigating. Here's something you didn't expect: auroras aren't exclusive to Earth. They occur on other planets as well. For example, Jupiter has auroras that are much larger and more powerful than those on Earth due to its intense magnetic field and rapid rotation. Imagine the colossal auroras on Jupiter, larger than our planet and glowing with a brilliant intensity. Mars, too, has hints of auroras, though they're more subtle due to its thin atmosphere and weak magnetic field. Astronomical marvels are not constrained by our earthly experience. But why, you might ask, are auroras predominantly visible in polar regions? This is where it becomes truly captivating. While the magnetosphere protects us from solar wind, its shape causes charged particles to spiral into the polar regions, creating a ballet of light that is concentrated near the Arctic and Antarctic circles. This creates what we call the auroral oval, where the chances of witnessing this natural wonder are highest. Imagine planning a trip to one of these regions, eagerly looking up at the sky, hoping to witness the phenomenon for yourself. The anticipation is half the magic. Let's delve deeper into the solar cycle, which is a fundamental force driving the frequency of these light shows. The Sun undergoes an approximately 11-year cycle of activity that can greatly influence auroral displays. During periods of solar maximum, the Sun becomes particularly active, emitting more solar flares and coronal mass ejections, leading to an increased likelihood of auroras. Conversely, during a solar minimum, the activity drops significantly, and auroras become less frequent. This cyclical nature means that if you're planning a trip to see the northern lights, timing your visit during solar maximum can significantly enhance your chances of experiencing this awe-inspiring phenomenon. One might wonder, can we predict when the auroras will appear? Well, here's something astonishing. Scientists have developed models to predict the likelihood of auroral activity based on solar weather patterns. By monitoring solar flares and disturbances, they can estimate when the Earth will be hit by an influx of charged particles, allowing for forecasts that can sometimes be accurate months in advance. Imagine receiving a text alert that the northern lights are expected to be particularly vivid that night. This cutting-edge technology bridges the gap between science and the ancient human fascination with these celestial displays. Another interesting aspect of auroras is their historical significance. Indigenous peoples of the Arctic regions have long revered the auroras, interpreting them through their cultural lenses. Some believe the lights to be the spirits of ancestors dancing in the sky, while others viewed them as omens or messages from the gods. The interplay of science and mythology reminds us that while we can unravel the mysteries behind the auroras, they will always hold a degree of enchantment, filling our imaginations with possibilities far beyond scientific explanation. We can't forget about the impact of Earth's weather conditions on aurora visibility. Clear skies are essential for a great viewing experience. Even in polar regions, clouds can obscure the lights, leading to frustration for eager observers. The interplay of atmospheric conditions becomes yet another variable in this cosmic equation. Who would have thought that not just the solar wind and magnetic fields, but local weather patterns could shape your view of such a purely celestial phenomenon? So far, we've explored solar winds, magnetosphere interactions, and the beautiful chemistry of atmospheric gases. But what if the auroras you're watching aren't entirely shaped by our atmosphere? Here comes a twist. Scientists have even studied how the Earth's own climate can influence the patterns of auroras. Some research suggests a link between long-term climate changes and the frequency of auroras, asserting that as our climate shifts, so too may the intensity and visibility of these lights. It's a captivating reminder of how interconnected our planet is, where climate, space weather, and atmospheric phenomena intertwine in complex and beautiful ways. By now, you've seen how multifaceted auroras are, but let's take a moment to pose a rhetorical question. What do auroras tell us about our place in the universe? Watching the northern lights isn't just about beautiful colors. It's an invitation to reflect on our connection to cosmic forces that have shaped our world for billions of years. Each time they shimmer and dance, they remind us of both the fragility and the magnificence of our planet's existence in the vast universe. But here's something truly astonishing. Many people are unaware that auroras can be seen in places beyond the poles. During particularly strong solar storms, auroras have been reported as far south as the United States, even reaching states like Colorado, Utah, and Wisconsin. So, if you're dreaming of witnessing this spectacular light show but don't live anywhere near the Arctic, don't lose hope. Each year brings new chances, and every storm holds the potential for expanded auroral regions. As we wind down our exploration, let's circle back to the question we started with: why do auroras happen? The interplay of solar winds, the Earth's magnetic shield, and the chemical reactions occurring high in the atmosphere are just the surface of a much deeper and richer narrative that involves our entire solar system and the cosmic dance of the sun and planets. What comes next will leave you speechless. Consider for a moment the implications of the auroras on our own technologies. In today's world heavily reliant on technology and communication satellites, the influence of solar flares and the magnetic disturbances they create can significantly impact satellites in orbit. By studying auroras and the conditions that lead to their occurrence, scientists learn about the space weather that could affect everything from GPS navigation systems to power grid stability on Earth. This knowledge allows us to better predict and prepare for solar storms, safeguarding our technology and infrastructure from potential disruptions. And here's your takeaway: the next time you gaze at the enchanting northern lights, you'll not only appreciate their beauty but also recognize their significance as a barometer for solar activity and their role in the broader tapestry of our cosmic existence. In conclusion, the auroras are not just beautiful light displays but also beautiful reminders of the interconnectedness of our universe. Every time they flicker and dance in the night sky, they offer us a glimpse into the dynamic and magical forces that govern our existence, reigniting our sense of wonder for the cosmos. As you finish up this journey through the science behind auroras, remember to look up at the night sky with a renewed appreciation, knowing that the northern lights are more than visual poetry. They are a testament to the powerful symphony of natural forces at play in our universe.